This video pertains to section 9.2 in your textbook from PreCalc 2 on hyperbolas. And we're going to be looking in this video on hyperbolas that aren't centered at our origin, so that we've translated them from our origin. If this is difficult, go back and watch the video on hyperbolas that are centered at the origin. That will help a bit. So a hyperbola is a conic section where this conical structure is cut. It's defined by its vertices, its foci, and these asymptotes that go through our center. The first step is to locate the vertices. The second step is to draw a rectangle that goes through our vertices and our co-vertices. Then we can draw the hyperbola, and we also want to be able to locate the foci. So those are the steps that we're going to use when we're evaluating hyperbolas. Okay, so our standard form looks something like x minus h over a minus y minus k over b, or y minus k, or the y can be positive. So if the x is positive and y is negative, we're going to be moving along a horizontal transverse axis to get to our center and our foci. And if a y is positive and x is negative, then we're going to be moving along a vertical transverse axis to get from our center to our vertices and our foci. Okay, and the equations are all here for our asymptotes and our vertices and our foci, and I will go through those graphically. They're also here if you want to pause it here and write them down, but I'm going to ask when they post this video that there's a document with all the equations that's attached in the comment section of the YouTube video, so that you have it there. If you're really a formula-based person, you can assign all of your variables and plug it into the formula. But we'll go through this graphically, one for the horizontal and one for the vertical. Okay, so we have a vertical transverse axis. We have x minus 3 divided by 4 minus y minus 1 divided by 1 is equal to 1. Sometimes you won't see this divided by 1. This is put into this problem just to make it really clear. So we have, I'm just going to rewrite this because it's kind of difficult in this format. I like to write it out like this, divided by 4. 4 is 2 squared. So I'm going to write it out like that straight away. Y minus 1 squared divided by 1, which is 1 squared, is equal to 1. So the first thing that we want to do is we want to locate our center. So our center from our standard format is our x minus 3, so 3 is our x coordinate, y minus 1, so 1 is our y coordinate of our center. And whenever I do this, I usually do this graphically. I go ahead over here, I'm going to plot this 3, 1 point right there. Okay? That's our center. So this is our center. Okay, now our vertices, because our x is in front, we're going to move whatever the square root of our denominator under our x value is from our center to get to our vertices. So what does that mean? That means this 2, I'm going to move 2 in the x direction to one vertices and 2 to the other. So we have a point here and a point here. Okay. So if you're mathematical, this becomes 3 minus 2, 1. And this will come from the formulas. And 3 plus 2, 1. I usually graph it and look at what my points are. This 3 minus 2 comes 1, 1. 3 plus 2 is 5, 1. So these are my vertices. Okay. Now we want to draw our box that our asymptotes are going to go through. So I'm just going to draw that in red. Our boxes are going to go through our vertices and our co-vertices. So our co-vertices, we're going to go up and down one from our center. So these are our co-vertices. And now we can draw this box here. Okay. And then we want to draw the lines that go through the corners of this, through the center and the corners of this box. Oops. Just trying to draw this as accurately as possible. When you draw this by hand, oops, by hand, you should draw these as dotted lines. And I know I'm not doing that here, and that's based just upon the limitation of the tool I am in or my technical ineptitude. I'm not sure which, but I think it's a limitation. I don't know how to switch this to make it a dotted line. Okay, so now we have our asymptotes, we have our vertices. We can draw, oh, we should probably write the equations of those asymptotes. So our asymptotes on this, our rise was 1, that's from our denominator under our x value. And our run was 2, or our denominator under our y, our run was 2. So we have a point, so we can use our point slope equation of our line, and we have y minus 1, because our center is 3, 1, is equal to 1/2. We rose 1 and ran 2 times x minus 3, because our center point was 3, 1. And then, so that's the positive 1, and we have 2. So this is y minus 1, and this is just negative 1/2 x minus 3. Okay, so those are our asymptotes, and now we can go ahead and draw. So we found our center, we found our vertices, we drew our asymptotes. So now we can kind of draw a hyperbola. And it's going to go through the vertex, and not touch the asymptote. Okay. The final thing we need to do is we need to find our foci. Now our foci, our c squared, again, is going to be a squared plus b squared. So that's our denominators. That's 4 plus 1 is equal to 5. So c is equal to the square root of 5. And if you want to graph that, the square root of 5 is approximately equal to 2.25. And again, we're going to move in our x direction. So we're going to put 1 here. We're going to move 2.25 in our x direction. So let me put this in red over here. We have a spot here and a foci here. That one's, and a foci there. So we're going to move from our center, and we're moving in our x direction. So we're moving from this 3. So our foci are going to be at 3 minus square root of 5, 1, and at 3 plus the square root of 5, 1. Okay, so that's a horizontal axis. Again, we found our center, we found our vertices, we drew our box and our asymptotes, and then we were able to draw our hyperbola and find our foci. So I'm going to clear all these drawings. We'll go to the next slide. So this one's going to have a vertical transverse axis. So we have, oops, I'm sorry. We have a vertical transverse axis in this example. Annotate. And I'm going to, again, just rewrite this as y minus 5 squared over 4 is 2 squared minus x minus 3 squared over 25. Oops, 25 is 5 squared. So we're going to put this as 5 squared is equal to 1. Okay. So our center we get from our points y minus 5, x minus 3. So our center is at 3. We move 3 in our x direction. We move 5 in our y direction. So this is our center. So I'm going to go ahead and put that on here. This is our center. Okay. Our vertices, because y is out front, we're going to move our denominator along in a horizontal axis from our center. So we're going to move down 2, and we're going to move up 2. So those points, if we move down 2, we become 3, 3. If we move up 2, we add 2 to 5. This becomes 3, 7. Okay. So now we can draw our box. I'm going to try and do this in red. We're going to go, we have our vertices, we need our co-vertices. So we're going to go 5 in our x direction. So 1, 2, 3, 4, 5 here. And that's 3, 4, 5 there. So we want to draw this box that's here. So when we draw a hyperbola, the hyperbolas go through the center, come on, the center and the corners of our square. And when you draw this, again, you want to draw these as dotted lines. I just don't know how to do that, so I'm not doing that. Sorry. Okay, and now we can draw, let's write the equations of those lines. Again, we're going to use the point slope format of a line. So we go through our center. Our center is 3, 5, so it's y, sorry. It's y minus 5. And you'll notice that's our numerator for our top. Is equal to our slope. Our rise was 2 and our run was 5. Our 2 and 5. So we go 2 fifths and our x minus 3. And same thing, that's the positive slope. And then the negative slope is y minus 5 is equal to negative 2 thirds x minus 3. So those are our asymptotes. Now we can draw our hyperbola. And again, we're going to go through the center and approach our asymptotes. We're bound by our asymptotes. So, okay. And finally, we want to find our foci. So we're going to move along our transverse axis, so in the vertical direction from our center, and we have to find what c is. C squared is equal to a squared plus b squared, so we're adding these denominators. So 4 plus 25, this is 29. So c is equal to the square root of 29, and this is approximately square root of 29, 5.39. So we're going to move we're going to move 5.39 from our center. 2, 3, 4, 5. So we have a foci here, and we have a foci up here. Okay, but we can write our foci as, again, we're moving in our y direction. So this is 3, 5 plus the square root of 29, and 3, 5 minus the square root of 29. Okay, so again, our steps are we find our center so that we can find our vertices. We're always going to move along the direction that has the positive value. So in this case, y is positive, so we're moving in our y direction to our vertices. We draw our box, we draw our asymptotes, and then we can draw a hyperbola and find the foci. Okay. There will be a final video on completing the square, so just one example of completing the square, and that should wrap up this section. I think there's some applications and stuff, and if you struggle on that, please sign up for an appointment and we can help you through those.